start the third class on integer. And here first we'll prove the number of prime is infinite, that we stated in earlier class. Number of primes is infinite. So that we prove first. And there are many proofs for number of primes is infinite. We will prove one. And that proof is done by Euclid. And so we start the theorem. Here theorem is the number of times the number of primes is infinite, and this is one important problem in B.Sc course. So how we'll prove the number of primes is infinite? How to prove? So we prove this theorem by contradiction. If possible let number of primes is finite. The number of primes is finite. Okay, and p be the, if it is finite number, so obviously this, since number is finite, so obviously by Euler principle it must have a greatest element. So and let we consider p be the highest prime or p be the greatest prime. So we write the primes, and since it is finite in number, so we can write the primes in that way: 2, 3, 5, 7, ... I said the highest prime is p in succession. Okay, while p is basically the greatest prime. Now we just take the product. Say let n equals to the product of all the primes. So 2 into 3 into 5 into 7 and p. We consider this number as the product is basically n, and in which every primes appears only once appears only once So, and then we can say then n is divisible by each of the prime numbers. Then n is divisible by each prime. Now we consider the numbers. Now we consider the number n plus 1. And this is also a natural number because it is the product of primes, and that is also a natural number. So obviously this number, this belongs to n, natural number. And here we can say n plus 1 is not divisible by any of the prime, and we say that, or therefore n plus 1, that means 2 into 3 into 5 into 7, p, that number plus 1 is not divisible by any of the primes. So hence this number is either itself, hence this number n plus 1 is either itself a prime, or being a composite number, it is divisible by, being a composite number is divisible by a prime number greater than p, is divisible by a prime number greater than p. Okay, so if it is a prime, so I said p is the highest prime, that will achieve the contradiction. Or if it is a composite number and it is divisible by a prime number greater than p, that means there exists a prime which is greater than p. That exactly violates the assumption p be a greatest prime. So which is a contradiction, which in the both cases we arrive at a contradiction. So which is a contradiction. So that's what we assume here. The number of primes is finite. This is not true. So that means, okay, why it is a contradiction? As in the both cases, that means it itself a prime, or being a composite number, it is divisible by a prime greater than p. In both cases, p fails to be the greatest prime. That's why it is a contradiction. Now, why the contradiction appears? Because we assume here the number of prime is finite. So therefore, our conclusion is the number of primes is infinite. So now we'll solve some important problem that is related to the division Euclid algorithm. So why we are using the Euclid algorithm? So what is the benefit of Euclid algorithm? So Euclid algorithm exactly help us. So right here, our next recall is here, Euclidean algorithm. So Euclidean algorithm basically is an efficient method to find out the GCD, or greatest common divisor, of two given integers. So this algorithm help us to find out GCD of two integers, where a square plus b square is basically non-zero. So we can find out the GCD of AB, where at least one of them is non-zero. So when we will find out the GCD of AB, in that case, this method involves repeated application of the division algorithm. Okay. So this method involves involves repeated application of division algorithm. So now actually by using different example and by using an Euclidean algorithm, we have to find out the GCD of any two integer at least one of them is non-zero or both of them are non-zero. So your first question, and that question is asked in Calcutta University examination under B.Sc course. So the question is, calculate the GCD, calculate the GCD, greatest common divisor of 567 and 315. Okay, this is asked for 3 marks. So how will calculate the GCD of this number? So just you will calculate here 567 315 by using division algorithm. So this number will be 315. That means it will be 252. Again you will divide 315 1252, and that will be 363. Again you will divide. So that we have done in our school level. So 63, that means 4 to 52, the remainder is 0. So that we will write here with the help of division algorithm. So how to solve? First we will write we have. So in that case 563, 567. This will be 315 multiple 1 plus 252. In the second case, so that is done for this case. So what we get here, 315, this is equals to 252 multiple 1 plus 63. Next, in this case, 252, this is basically 63 multiple 4 plus 0. So here the last non-zero remainder, that will be the GCD. So here the last non-zero remainder, the last non-zero remainder, that is basically the GCD. So here you will see this is the remainder. In that case, here all the remainder term is present in here. So the first non-zero remainder is 252, second non-zero remainder is 63, then the remainder is 0. So here the last non-zero remainder is basically 63. So therefore GCD of 567 315 with the help of Euclidean algorithm, that will be the last non-zero remainder. It will be 63. As the last non-zero remainder, the Euclid algorithm, non-zero remainder, this is basically 63. So what we calculate here, the GCD of 567 and 315, this is basically 63. Now we come to the next important problem. This problem also asked in Calcutta University Honors Examination. Calculate the GCD of 63 and 55, and with the help of division algorithm. Again, just you will do your rough work. So first 63, that will be 55 into 1 plus 8. So here 63, 55, 53, 8. Again we will divide 8, 53. So 6 into 8, 48. So it will be 7, then 8, 7 into 1, 7, then 1, 7. So here you will see the last non-zero last non-zero remainder is 1. Okay, so again 55, that will be 8 multiple 6 plus 7, and next 8 is equals to 7 multiple 1 plus 1, and 7 is equals to 1 multiple 7 plus 0. So here the last non-zero remainder is 1. So therefore, by Euclid algorithm, GCD of 63, 55, this is basically 1. Because since 1 is the last non-zero remainder, so that's why here the GCD will be 1. Now here we know, here one important recall. The recall is if GCD of AB equals to 1, that implies if and only if there exists integer u comma v belongs to z such that au plus bv equals to 1. Similarly, if GCD of AB equals to some d, if and only if there exists integer uv belongs to z such that au plus bv, that will be d. Okay, so by using this recall, we must express the GCD as the form au plus bv if the GCD is d. So now the question asked in Calcutta University Honors Examination. The question is express GCD of 567, 315, that is in the form 560u and as 567u plus 315v. Okay, while u, v are integers, while u comma v are integers. So how to solve this kind of problem? Again, the marks is here 3. And how to solve this problem? Here we have seen the first part will be you calculate the GCD of so here first step, or you can say step 1. First we will calculate GCD of 567 and 315. So how to calculate that? I said, okay, 567, 315. If we divide this number, that will be 1315 and 252, and again 315, 252. So 63, 252. So 4, 252. Remainder is 0. So that we will write here. We calculate. Say we have 567. This is equals to 315 multiple 1 plus 252, and 315. This is 252 multiple 1 plus 63, and 252 this is 63 multiple 4 plus 0. So since the last non-zero divisor remainder is 63, so therefore we can write GCD of 315 and 252, this will be 63, as or since 63 is the last non-zero remainder. So when you will find the remainder after the GCD, after that you will continue with step 2, and in that case, so you just move reverse. Okay, how will move reverse? So start from here, because we get the remainder 63, and from that information we can write 63 equals to 315 minus 252 multiple 1. That we can write. Now we can replace the number 252. Okay, so 315 minus what exactly 252? 252 means 567. 567 minus 315. That is basically for this line. So it can be written as 315 and 315 multiple 2 2. So that we can write in that way, 567 into minus 1 plus 315 multiple 2. That way we can write. So that means here this 63 means GCD of 315 252. That we have written as 567U plus 315V. What is U? Where U equals to minus 1 and V equals to 2, and both are basically empty. So we have done with the help of two steps. We have expressed GCD of 567, 315 as 567U plus 315V. Okay, so in that way we can solve this kind of problem. So here you have asked another problem. Say find integers. Next, this is question 4, question 3. Now we come to question 4. Question 4. This is also important. Find two integers. Find two integers U and V satisfying 54U plus 24V. This is equals to 30. Now the question is how to solve this kind of problem. So first, what should be step 1? Step 1. So first you will find the GCD of, when you have asked this kind of problem, the sum lambda u plus mu v equals to delta. So first you will find out the GCD of lambda and mu. Just to compare this. So first we will find out GCD of 54 and 24. Okay, that we have to find out. This is our first work. We will calculate GCD of these two numbers. So what should be the procedure? 54 24. So this should be your rough one. So that will be 248 and then 6 24. So here the remainder is 0. So what we will write? In that case we have 54. This is equals to 24 multiple 2 plus 6, and 24 equals to 6 multiple 4 plus 0. So here last non-zero remainder is 6. So therefore we can write GCD of 54 and 24. This is basically 6, as 6 is the last non-zero remainder. So here we just applied Euclidean algorithm, and by applying this Euclidean algorithm, we have find out the GCD. Now for step 2, we just move backward. Backward means here we can write. We'll start from this line where we have find out the GCD, last non-zero remainder. So we can write 6 equals to 54 minus 24 multiple 2. Okay, so that means what is 6? 6 is basically GCD. So just to think on the right hand side, it is given 30. So I made it 30, just multiplying both sides, 5. So 6 into 5. So 6 into 5, that means 30 equals to 54 into 5 minus 24 into 10. Okay, just multiple on the both side 5 because I need 30 on the right side. So what we get? We get here 54u plus 24v equals to 30. What is u? Where u equals to 5 and v equals to minus 10, and both are basically integers. So we have find out the integers. Therefore, the integers u and v are the integers u and v are 5 and minus 10 respectively, which satisfies 54u plus 24v equals to 30. So this is also the question for 4 marks, and we have done this problem now.